we'll be monitoring that. But I just wanted to welcome everybody and thank you for joining today's webinar on what's new with NFPA 70E 2021. My name is Chad DePasquale and I'm the Vice President of Services for HESCO. We are excited to be collaborating with PowerHawk to present today's topic on arc flash and to bring more awareness of electrical safety to our customers. So we'll start off with a quick overview of where does NFPA 70E come from, how it relates to OSHA, and if it is code. We'll then dive deeper into arc flash to cover topics like key definitions, how working de-energized is the expected norm, risk assessments, and PPE. We'll end with what has been updated in the 2021 version of NFPA 70E and the significance of those updates depending on your role. We're planning time for Q&A at the end of the presentation, but feel free to unmute yourself at any time and ask questions during the presentation or send them in via chat. We'll be monitoring that and bringing them up to get those questions answered for you. So every attendee will also receive a copy of the slideshow you'll be seeing today, along with a link to this video recording, and keep an eye out for that in the next few days in your email. With that, I'd like to introduce our presenter today, Mike Balinskis. Mike is the Vice President and General Manager of PowerHawk, an engineering and technical services company located in Farmington, Connecticut. Part of the Falcon family of companies, PowerHawk has completed hundreds of arc flash risk assessments for all types of customers across the Northeast and beyond. Mike has led the arc flash practice since 2010 and has provided electrical safety training related to arc flash and shock hazards to dozens of companies along the way. A degreed engineer by trade, Mike has worked in the utility and electrical business for more than 35 years. Mike, thanks for being here today. And with that, I will turn it over to you.
Thanks, Chad. Now that you all know that I'm an old guy and that I'm standing between you and lunch, let me see if I can get this screen share started. Oh, there we go. Does that look good to everybody there?
Looks great.
Yep. Looks okay, good on my side.
Looks good.
Looks good here.
Okay. Well, again, welcome. And you got a little overview of what PowerHawk is. We've been doing this for quite a while. I know a number of you out there in Zoom land, and welcome you all here this morning. You know, PowerHawk is a little bit unique in that for us, this isn't just sort of an engineering topic. We have folks that go out in the field every day. We're affiliated with McPhee Electric and a number of other electrical contracting firms. So to us, it's very real. It's about human safety. We have to look the people in the eyes every day, sending them out. And, you know, really, this is all about ensuring that everybody gets to go home at night. Everybody gets to do their job and everybody is safe. You know, so that's really, this is more than just an engineering exercise to us, I guess, is the bottom line. So with that, we'll jump in here a little bit. First, as Chad indicated, what we'll do is kind of, so we can get everybody oriented, do a little overview of some key issues related to arc flash and NFPA 70E. Then we'll look at some of the changes that are in this current version that just was adopted. And as Chad mentioned, we'll certainly have time for questions. If along the way you've got something that you have burning to be answered, certainly pop that in the chat box there, and we'll try to get them as we go. I would just say, you know, and I hopefully I don't lose half the audience here, but the Cliff Notes version of this is really there are no major changes. This standard has been around for quite a while, and in the earlier years, between the early 2000s, let's say, and 2012 version, there were some pretty major changes when these update cycles came and went. What you really see now is a continued refinement of the standard, and I'll show you as we go along here some of those refinements, some of the realignments, some of the tweaking, and some of the things that have been impacted over the years. What we see this year, another kind of highlight, though, in this standard, we're seeing a continued increasing emphasis on safe working practices, the policies, procedures, and checklists. So if this is new to you, this is something that you're going to want to pay attention to and start to look at to build out your plan for your facility and your employees. One of the other bigger changes is, and we'll talk about this more a little bit later, is the updated IEEE 1564 standard that came out in 2018 that impact the calculations of incident energy when doing arc flash analysis. So, we'll talk more about that in a bit, but the importance there is really, I think, for most end users, is this IEEE update has the potential to impact the scope of work that you get defined, or that an engineer will define for you when doing these assessments. So we'll talk a little bit more about that, but that's sort of the highlights of what's in store on this next version of NFPA 70E. So a little sort of start at the top, and we'll work our way down. The whole idea of NFPA 70E is centered on electrical safety, and it really comes from OSHA, the Occupational Safety and Health Administration, which many of you probably have heard of. Hopefully, most of you have not had direct interaction with. So OSHA has what's known as the General Duty Clause. The General Duty Clause is a very wide and encompassing standard that basically says, as an employer, you're supposed to keep your employees safe from known hazards in the workplace. It doesn't say electrical safety, it doesn't say mechanical safety, it doesn't say anything about NFPA 70E per se, or any of these other sorts of things. It's really a very general standard, so it has wide application. NFPA 70E is a standard that, again, was originally developed in the 90s and then on a 3-year cycle of improvement. Originally, a lot of the pieces were in NFPA 70. NFPA is the National Fire Protection Association, and that's the organization that builds standards like, you may be familiar with NFPA 70, which is otherwise known as the National Electric Code. Those parts and pieces that had to do with electrical safety were sort of pulled out, and this separate standard 70E was created, and since then has been continually refined on a 3-year basis. So today we're really going to focus in on the 2021 version that's in front of us now. So OSHA has the General Duty Clause. NFPA 70E really talks specifically about electrical safety in the workplace. And then IEEE supports both of that and supports 70E in that this is where the engineering calculations come in to guide how the arc flash hazard analysis, the incident energy, and ultimately what gets you to PPE, personal protective equipment for your employees. This is how it all sort of flows together. This current standard was put into effect June 21st of last year. Really, it's about interactions with energized electrical equipment. That's kind of key. This is not about just opening up a door and seeing gray boxes. This is really about workers that are involved with energized parts and pieces and their interaction with that. NFPA 70E is not code. It will likely never be code necessarily, but it's known as a national consensus standard. It is not been adopted by OSHA, and OSHA doesn't mandate specifically compliance with 70E. However, if you should be so unfortunate to have to deal with an injury or death due to an electrical accident, OSHA and if OSHA determines that if you complied with 70E, you could have prevented or lessened this, then that's where the citation would come in. In general, OSHA will say that you have to have a program in place to keep your people safe from known hazards, and the electrical hazards included. 70E helps you do that, but they don't go as far as saying that you must follow 70E. You can do 70E or you can do something else. But in essence, 70E is a great guide to help you get that done. So that's sort of where it all comes from, and how they all fit together. What I've tried to do throughout the presentation, you'll see as well here, is try to cite the various sections of NFPA 70E as we go along. So if you're looking for specific references to things I've talked about, you should be able to go into the standard and find them right there. So arc flash, for those of you who may not be as aware, it's really hot, really fast, and really loud. It's this uncontrolled discharge of energy. It has tremendous amounts of energy that human beings are generally just not able to deal with. So our skin is not able to deal with 35,000 degrees. These are very powerful concussive forces. In some cases, the components do not even necessarily have to touch each other for these arcs to occur. They can flow through ionized air, and we're going to be talking about a couple different kinds of hazards in the electrical world: arc flash and then shock. Those are two separate things, two different ways of leaving the earth potentially, but or ending up in a hospital. But they are different things, and as you go through these programs and NFPA 70E, both of those things are sort of addressed. For those of you who may have not seen an arc flash before, I'm going to show you a quick video here, if everything works. Some of you may have seen this before. This is a 5 kV, 5,000 volt piece of switchgear. The operator is racking a breaker in or out, not really able to tell. And you can see by this explosion, pretty dramatic, very directional, and just something that you don't want, you never want to be, nor do you want your employees to be involved with. So serious stuff, and something that we certainly need to avoid. In Article 100 of the standard, there's some key definitions that really frame how we are supposed to think about this whole idea of arc flash and electrical safety. The objective of the standard, the objective of your policies and procedures is to create an electrically safe working condition. As you can read there, I'm not one that likes to read verbatim from the slides. You can all read and hopefully see this, but really the idea here is to either, if possible, eliminate the electrical hazards to people by de-energizing these parts and pieces that they would have potential to be in contact with. So there's a lot of moving parts, procedures, policies, as I said, checklists, and engineering analysis, all pointing toward working toward this idea of an electrically safe working condition. So keep that in mind, because that's really the sort of the penultimate objective of here. We can't be putting people in front of known hazards while working. The other key idea is those people we are going to have interact with these kinds of conditions are known in the vernacular of this standard as a qualified person. So you'll see here, skills, knowledge, and training are the three keys to determining who's a qualified person. This idea of having people work on energized systems or trying to work to de-energize systems is really has this main caveat, and I'll talk a little bit more about some other things in a few minutes about it being done by a qualified person only. Doesn't say they need to be an electrician, doesn't need to say be an engineer. A person can be qualified in a particular facility, that they have skills, knowledge, and training related to the systems in that facility. And yet, if they went to another facility, they would not necessarily be qualified. So the idea of a qualified person is key. It's also the responsibility of the owner of the facility to determine who they are going to designate as a qualified person. And everybody else is unqualified in this set of terms, and is really not supposed to be being involved. And this goes all the way to PPE. You know, the logic there would be an unqualified person doesn't have the skills, knowledge, or training to even understand the hazard. How would they know what's the proper PPE to choose to work safely? So again, electrically safe work condition and a qualified person. Finally, this idea, the safest way, and as a last resort, safest way is to work de-energized. A last resort is to work energized. This is sort of 180 degrees out of phase with the way most electrical workers have come into their craft and trade. Anybody that's sort of older than probably 30 or 40 years old in the electrical business learned their apprenticeship working on energized parts. So for a lot of folks, this is a major change. But you need to be very clear, working energized is now the exception. It is not the rule. Working de-energized is what OSHA and what NFPA 70E are expecting and asking and wanting people to arrive at. So the idea of working energized is going the way that we've worked for many customers, and that have they call it no hot work policy. I'm assuming a lot of you out there probably have those. It's surprising how in these last 15 years that whole idea has been turned on its head, that you do not want to be the contractor on a site working energized these days, because you'll likely be the last day you work for that client. So working de-energized, we'll keep reinforcing that idea, but that's really key here. There are a few exceptions you'll see in Article 110.4 to this idea of working de-energized: when it creates a greater hazard, when it's infeasible, and when it's less than 50 volts. You know, if we have people on life support systems, de-energizing that circuit to work on the circuit can create a greater hazard. You know, just an example. Infeasibility, if you have a certain industrial processes that by shutting them down, you would create greater hazards or increased hazards. Fire pump circuits, refineries. The system may not have the feasibility due to design or operational limitations. They're far and few between. Not a lot of people that we've met that meet this criteria. And it's important to point out here that cost and operating inconvenience, if it takes you, you test it at the extreme, it takes you 24 hours to shut this process down and thousands or tens of thousands of dollars to do so. That doesn't meet the infeasible criteria. Inconvenience and cost are not infeasible. OSHA does not care how much it costs you compared to a human being's life. So again, remember that, and I get it. We deal with this all the time, working with customers, trying to figure out how do we work deenergized for maintenance and so forth. How do we shut this stuff down? How long do we have? What sequence do we have to use? But the idea of infeasibility is one that's really rare. One exception, and again, the exception here is at the very bottom, has to do with, again, that main caveat. This applies to qualified individuals. Qualified individuals can work testing, troubleshooting, and voltage measurement as an exception to working de-energized. You really can't do testing or troubleshooting or voltage measurement if the circuits don't have any power in them. So you need the potential there to measure that. So that's really one of the only exceptions. There are different nuanced exceptions for infrared inspections and for visual inspections as well in the standard. So those are kind of a pretty narrow group of items that you can consider, and again, really only applies to qualified individuals. When we talk about arc flash risk assessments, Article 135.5, most customers are familiar with the idea of installing labels on the equipment to identify the hazard on that piece of equipment. And the process that we go through to do that is pretty involved. It's not an inexpensive endeavor. And the other thing is, once you do it, it's really not a one-time deal. This is sort of the truth in advertising. If you're going to start down this road and you're going to do an arc flash risk assessment, understand that in essence, by default, you are making a commitment to a safety program that's going to go on for almost as far as the eye can see. There are reviews that are required. There's training that's required. There's maintenance that's required. You can't just do this once and forget. You can, but it's sort of almost a waste of money. We'll talk a little bit more about that. So it really entails collecting data on your system, probably 50% of the cost, and these are mostly for existing installed systems, is going to be to have crews like we have that will go out, wear the proper PPE, open up the equipment, and catalog and detail every part and piece of equipment, how long it is, what size it is, manufacturer style type model, all on the way to developing a one-line analysis model. And ultimately that analysis model is what's used to then develop the labeling that ultimately ends up on the piece of equipment. A lot of different ways to get that done. We self-perform all that work from soup to nuts. So we have qualified people that go out in the field and collect this data and then build the models and then follow through as a turnkey project. Typically, the analysis starts at the utility entrance, where the utility connects to the building and goes into the system down through the 240 volt or 208 volt levels. We'll talk a little bit more about this when we get into the IEEE details, but as to how far into the system you really need to go. But you want to go far enough so that you're producing information on arc and shock boundaries and PPE levels far enough into the system to protect your workers. Generally, you're not doing arc flash on single phase systems. This is generally a three-phase phenomenon, and generally single phase is not included. A couple other key ideas related to completing an arc flash, and this kind of goes, some of this goes a little bit what I was saying just a minute ago about the commitment to go into this arc flash and electrical safety. When you're ultimately what you're looking to do is to provide information to qualified individuals to keep them safe, to allow them to have information to select the proper PPE to keep them safe to do their work. There are really two methods. So 130.5F says that you can use either an incident energy analysis, which is otherwise known as an arc flash risk assessment, or the arc flash PPE category method. This is a method, if in NFPA 70E, there is a set of tables that would allow you to sort of go through a decision tree and determine what the PPE is using that method in lieu of the incident energy analysis. The preferred path is still the arc flash risk assessment, but there are these two methods. I mentioned in passing just quickly that another informational note. So you have different sections, and then some of these sections have these things called informational notes to kind of clarify what they're after. Bottom line here is you're trying to figure out what's the proper PPE to wear for qualified individuals. What this informational note is saying, if you don't maintain your equipment properly, or if it's not installed properly, the PPE selection is basically may not provide you the right information. That's why it's so important, either before or after, and certainly going forward, equipment needs to be maintained. The arc flash risk assessment assumes, and there's also some modifications to how we look at these issues going forward, assumes that equipment is going to operate the way it was installed and intended to operate. If it's not been maintained in 5, 10, 15 or more years, it is certainly not going to provide the level of protection to the employees and the system that it was intended. So maintenance is a big issue. And then also every 5 years, unless there is a major change or update to your electrical system, these arc flash risk assessments should be updated. And usually it's a fraction of the cost of the original analysis, but you need to stay on top of this. It's something that, like I said, once you do it, you have to stay committed to keeping it accurate and reflecting any changes in your system if those do occur. Again, reinforcing this idea of working de-energized. This is a classic hierarchy of risk inverted triangle that is intended to kind of portray the idea that elimination of these hazards is really the ultimate and ideal goal. Many times we come across questions from folks, and people are heading right for, just tell me what the right PPE is to wear for to protect my people. And it's basically an impossible question. Without analysis and without understanding, it's really not possible to do that. And frankly, we're looking at the wrong end of the horse. PPE is the last resort. I say this in some of our training classes. PPE is not a Superman cape. It will not protect people from all bodily harm and injury. As a matter of fact, the PPE is designed to limit the exposure to the human inside of it to less than a second-degree burn. So if you're involved in one of these flashes in proper PPE, you can still very well end up in the hospital, but with a survivable, non-life-threatening, non-permanent injury. So again, it's finding the right PPE. We don't even want to be in PPE if we don't have to. We want to eliminate the hazard. And so this is really from a thinking point of view, from a how do we attack this issue point of view, this idea of elimination is really what we're after. So let's dig into some of the updates on the standard. So as I said, June of this year, the standard was issued and then made effective. The standard itself, this booklet, if you don't have a copy of it, I would certainly recommend if you're a maintenance person or a maintenance manager or a safety manager, it really is a good book in terms of a resource. It has a lot in there, not just sort of chapter and verse and definitions and things, but examples of policies, examples of checklists. It really helps give you a how-to of putting a program together and some tools to keep people safe. Costs about $85. You can go on this website at nfpa.org and either as a member or non-member purchase it. You can also sort of a little cheaper way, if you will, or a fast way. You can actually go to this website in here that I have highlighted, and NFPA actually makes previous versions of NFPA free. You can download a free PDF of the 2018 NFPA, and the reason I tell you that is because, frankly, a lot of the stuff that's there stays there and doesn't move tremendously. So if you had a copy of the 2018 NFPA 70E and that's the best you could do, you're still doing better than not having any. It's kind of a cheap way to kind of see what it is and get your hands on it. So if you don't want to spend the $85, at least start there. The standard, this 2021 standard really did some reordering and reshuffling of some of the topics in there, but what it sort of points to is this idea of reinforcing the idea of hazard elimination and development of an electrical safety program. I'll show you a little bit more about that in a second. This topic of labeling, lots of times we get questions of folks that, well, what does this mean if I've already done an arc flash risk assessment? So if you already have, it doesn't, and you do not have any major changes to your electrical distribution system, if you had valid labels in place at the time the arc flash risk assessment was completed, at the time it was completed, this update to the standard does not require you to make any changes to go back and replace your labels. For anyone who has not done a risk assessment arc flash, and is sort of new to NFPA 70E, kind of digging into it, I would recommend that you sort of start with the policies and procedures to kind of frame out what you're going to be doing, and as well, and we can help you with this as we go along. This IEEE 1564, which is the engineering standard, the importance there is to help determine what the scope of the analysis should be. That's one of the changes that we'll talk about in another second here. So if we dig in, Article 100 is a definitions section. This was, frankly, mostly housekeeping, nothing major here. Deleted a couple terms not being used, you can see there. Changes to a couple of terms to match the NFPA 70, the National Electric Code. I'll give you an example. In the 2018 version, under the term balaclava, they defined it as an arc-rated hood that protects the neck and head except for the facial area of eyes and nose. In this version, they say an arc-rated head protective fabric instead of hood that protects the head and neck except for a small portion of the facial area. So they go through these iterations and try to, in some cases, make it more relevant. In other cases, try to be less specific so that it can encompass a wider range. But I just give you that as sort of an example of the tweaking. That's why I think I can stand here or sit here and say, I don't think there's there's no major changes. A balaclava is still a balaclava. Most people know what that is, whether you're going to call it a rated hood or a head protective fabric, that's sort of a fine point. So not much change in the area of definitions. Article 110, which is really general requirements, had some pretty major reorganization. The thing to focus on here is really this section 110.1 pulls this idea of hazard elimination right to the forefront of the whole section, and frankly of the whole standard. So what they've done is sort of reinforce and re-emphasize this idea of program planning and policy. Just don't head for the arc flash assessment. Just don't head for the PPE. Put together a program planning and policy so that you sort of have this framework. And you can see as you go down the slide there, some planning items, some policy items, checklists for lockout, tagout, really good references. Again, as if you haven't ever dug into them, I would suggest you do, because it gives you a good way to think through some of this stuff, including job briefings as well. If you do have any of this stuff, I would also say take a look at it, because I think it can help you modify and round out what you have. This last point on the bottom there, 110.8, this really sort of should have been understood, but they made it very explicit in terms of clarifying that only qualified persons should be using test instruments and equipment. Voltage testers and various kinds of meters are not for a casual user. Again, voltage testing, you should have the proper PPE on, the proper shock protection on. A person who's not properly qualified may not even understand the limitations of the test device that they're holding in their hand. Test devices are rated. Testing a 1,000-volt circuit with a 600-volt rated piece of test equipment is a recipe for disaster. So again, reinforcing this idea that only qualified persons should be involved in anything having to do with energized circuits, including the testing of those circuits. Article 120, dealing with establishing an electrical safe work condition. A couple of important points here, because we see this all the time. We're working with customers and asked to come up with a lockout tagout plan for doing de-energized maintenance, and you say, okay, well, what drawings do we have? What diagrams do we have? And we get the deer in the headlights. And so it's very difficult and very dangerous. I'm not going to explain to you the situations I've been in, but have been in, where the assumptions that we made ended up being wrong. We were fortunate to catch it, but especially when you have multiple sources of energy, backup generators, emergency generators, any kind of systems where you don't have proper documentation, very difficult. So the standard is sort of calling out that suitable documentation, including up-to-date drawings and diagrams, is really important for your lockout tagout procedure. By the way, one of the solid byproducts of an arc flash risk assessment is an up-to-date one-line drawing of your electrical system. So that's a great resource to have and to be able to use. It was sort of right after the 2018 version, Panduit came out with this device, and there was a little bit of a kerfuffle in the standard world as to how this would work or not. But and the reason we call Panduit out, this is a device that we install, that HESCO can provide. Really a great device to help eliminate the hazard of a qualified person having to go in and expose themselves to testing for verification for absence of voltage. Got a quick little video here. So really what you have here is just sort of an example of all the steps required to go through and test for the absence of voltage. So it can take some time. It also means that you're having to put somebody in PPE in front of and exposed to energized parts, as opposed to pressing a simple button on the outside of a device to determine whether or not that system has been de-energized. So a nice device. And what the standard did this time was really to clarify the use of these devices. And you'll see here exception 1 through exception 7 about using these. Hang on, excuse me for 1 second. There we go. Sorry about that. So clarification about how these devices are to be used, and really they've done a good job at relieving any ambiguity about of the ability to use these in your systems. If you have any questions about that, you can certainly talk to the folks at HESCO or ourselves, and we can help you understand where the application of these things would be best used. It's a great mitigation tool for arc flash if you've done it already, or even if you've not done it and you've got a lockout tagauts procedure and are continually looking to improve that. This is a way to add to that at a very reasonable price. So the section 130 is really reinforces this idea of shock hazards. So if you haven't done a shock assessment, and generally those are included in an arc flash risk assessment, this goes through a process, again, like a decision tree of estimating likelihood and severity. So another way to kind of think about that. It's a new discussion on that, as well as there's a new table regarding use of rubber insulated gloves. It talks about the length of the cuff of the protector glove in relation to the insulating glove. I did a little checking on this, and this really sort of stems out of the ASTM, which is a standard testing, American Standard Testing organization that really sort of sets how these devices are tested. Sort of the good news, though, is most of the manufacturers that we've seen already meet this table, but it gives you, again, another piece of information to help workers ensure that that we're matching the right parts and pieces in the system of PPE that we're providing for folks. As I mentioned along the way here a little bit, this is something called Annex. The standard has a number of annexes in it that are sort of expansions of topics throughout the standard, and they're actually very, very good. This Annex D, as I mentioned, deals with the IEEE 1584 2018 calculation method. The previous version in 2002 was a first shot at trying to figure out how do you actually calculate the energy that is created and dissipated through these arc flash incidents. And this 2018 version refines that, and there's many more tests that they did to try to do this, which you'll see there in the bottom of the bulleted items: electrode configuration, enclosure size. So they brought in a number of other variables into the calculation methodology, the data collection methodology, to try to improve the accuracy of the analysis. The challenge with this is, however, that these pieces combined with this section at the bottom, D4.57, we used to use under the 1584 2002, we used to use sort of a cutoff point of you'd go down into the system until you hit a point where the voltage was 240 volts or less, fed by a transformer of 125 kVA or less, and that kind of defined the lower limits of your analysis scope. So this 1584 2018 has changed that, and what you see here now is this idea that 240 volts or less and 2000 amps. So the difficulty is it's not possible to know when you're scoping a project where you're going to have a short circuit current of less than 2000 amperes in your system. So what we're working on now is trying to come up with a way to properly identify how do you scope the analysis down to a certain spot in the electrical system, and then do some analysis, and then if you have to keep moving forward with more analysis. Because the problem is, the further you go into the system, the more data has to be collected, the more expensive it gets, and we're always try to be very keen on trying to make sure we're providing good value. And it makes no sense to boil the whole ocean just because you can with a project that's so expensive that nobody will likely do it. We want to try to find that appropriate balance between how can we protect people the most, and at the same time not waste money just because we're not using our heads to try to figure out where that cutoff ought to be. So there are still some things that we're kind of trying to figure out and develop as we go forward as well, in terms of how far we go down into these calculations. But that's sort of a little thumbnail on that piece. So really, we're getting to about the time here that we have, and as I said, I'll just sort of wrap up here a little bit. No major impacts to existing or completed risk assessments, arc flash risk assessments. So if you have them, this update to this standard does not require you to do anything new. It does really reinforce this idea of not only the arc flash risk assessment, but the policies and procedures to electric safety, overall. It does a nice job clarifying these automatic voltage testers, and they're an accepted means to verifying for absence of voltage. As I just pointed out, IEEE 1584-18 is we're still trying to figure out that a little bit to make sure we're providing customers with best value in scoping out their work. And we sort of start and end with this idea that this is really all about working de-energized, and that it's not the exception, it's the expected norm. So I know we've come a long way in the last 10 or 15 years. When we first started doing this, people were really pushing back on this idea. I think this is certainly more and more people, if not the clear majority, are in this area already. But if for some reason you're not in this camp, you need to get here, because it's just not acceptable anymore to put people in front of these hazards when we can do better. It's not always easy, but we can do better. So I hope this was useful to you. There's a lot there. This is just scratching the surface of the detail in there. We're happy to help you if you need the help between us and the folks at HESCO. Happy to take any questions if there are any. Chad, do we have any in the chat box?
No questions yet, and maybe we'll have some coming, or if people want to mute their microphones and ask them, that'd be great. And maybe to give them some time, I was thinking of some questions here. And if someone did want to do this themselves and take this assessment on, what would you recommend their first step be in doing that assessment? And then kind of second part of that, while they're doing the assessment, are there any gotchas they should look out for? Stuff that you have seen overlooked in the past that are kind of critical to the assessment.
So if you're talking about an arc flash risk assessment, I think you saw in one of the slides there was a reference to the PPE method. So first of all, you would certainly need to have a copy of NFPA 70E, because if you're going to want to do it yourself, you really need to have this sort of cookbook to make the stew. I mean, you can't just go winging this stuff. So 70E will give you the how-tos on most of that stuff. If you're not going to do the full computer model route, you can use, I'll flip back up here for a second here, this arc flash PPE category method. Again, as I said, it's like a decision tree on how to select PPE. That's not a bad place to start. It will at least get you in the ballpark. It'll be more conservative maybe in some cases. And the other important piece is you need to determine who's a qualified person. The last thing you want to do is be putting somebody who doesn't have skills, knowledge, and training to in front of these hazards. So that's really a critical piece. Without getting into buying software and having engineers on staff, it's a pretty complex analysis. It's not a do it your DIY kind of project. You need to have some engineering horsepower to help you get it done ultimately. And the second part, Chad, was what? Oh, gotchas. What are some things that are overlooked? You do need to, when people first started doing arc flash risk assessment, one of the things that they did was they assumed the utility sort of at a maximum. You really can't do that. You really need to get the appropriate utility available short circuit current information, available fault current information, because the problem with arc flash is that it's not necessarily intuitive. You would think that higher voltage, higher current systems or devices would have worse risks, worse incident energies, and that is not always the case. I use the example all the time of having a 480 volt circuit feeding a 480 to 120 208 distribution transformer to a 120 208 distribution panel. Very, very classic common construct, whereby the 120 208 distribution transformer, the panel, I should say the panel, has a higher incident energy than the 480 volt panel feeding it. It's sort of, you can't just sort of assume by what size it is, how old it is, where it's located in the system. So making assumptions is pretty dangerous. So a couple of ideas there.
Great. We did have a question come in, and it is, after de-energizing equipment, is it necessary to put on arc flash PPE to verify the equipment has been de-energized?
Yes, a qualified person, again, that's key, you have to assume that it is energized until you verify that it is not. The interesting thing about this AVT that we showed here is that device allows you to verify the absence of voltage without opening up the cabinet, without having somebody put their PPE on, and without having to use a test device. This is a pretty ingenious and well-engineered device that allows that to happen. But to answer your question, yes, a qualified person needs to assume that it is energized until you test that it is not.
Okay, great. And we'll just give it a little more if anybody wants to unmute themselves or send over a chat message.